All right, in this tutorial, we're going over the big ideas geometry section 8.2, proving triangle similarity by AA. So AA stands for the angle-angle similarity theorem, and we're going to be able to use that theorem to solve some real-life problems by proving triangle similarity. So angle-angle theorem says that if you have two angles of one triangle that are congruent to two angles of another triangle, then the two triangles are similar. So notice how in the diagram, you've got your blue triangle ABC, red triangle DEF. A is congruent to D, and B is congruent to E. All you need are two angles to be congruent. The reason for this is we know that all three angles add up to 180. So if we're given that two of them are congruent, then the third one has to be the same in order for all of those to add up to equal 180. And if all three angles are going to be congruent, then the sides have to be proportional to match up with your congruent angles. So we don't even need to check if all of our sides have that same ratio of proportionality. We just need to find two angles that are congruent to make them similar, as long as they're corresponding as well. If they're, A and F are congruent, then that's not enough to say angle-angle. So let's look at our first example. We're given two triangles and we need to determine whether they are similar, and if they are, we need to write a similarity statement. So we've got CDE and GHK. Because both of those are right angles, they're both 90 degrees, D and G is one pair of congruent angles. Based on that triangle angle sum theorem, we're going to look in the first triangle to find what the angle measure of E is. And we take 90 plus 26 plus that angle E to get 180. Subtract that and we find that angle E is actually 64 degrees. And you should notice that that is the same measurement as our angle H over in the triangle to the right. So that is the second pair of congruent angles, which means that we can say by the angle-angle theorem, D, G, E, and H are all congruent. So our similarity statement, making sure that the order is consistent, triangle CDE is similar to triangle KGH. So one way that you could look at it is by assigning it to colors of different angles to help you write your similarity statements in the correct order. So we're going to again show that two triangles are similar. So this first triangle, you have ABE, which is that little one at the top, and then triangle ACD, which is the entire triangle as a whole. So we're going to look and find to see if any angles are congruent between ABE and ACD. And notice how if we separate them, you see that there are both angle measures of 52. So B and C are going to be congruent to each other. Then because they are actually overlapping by the reflexive property, angle A is congruent to angle A itself when they are overlapping each other. So those are your two angles that are congruent to each other. Based on the angle-angle similarity theorem, you can say that those two triangles are similar. All right, so now looking at triangle B, it looks like you have two different triangles with a set of parallel lines. You have SR and TU are parallel, and then they're intersecting at point V. So we know based on the vertical angle theorem that angle V on both sides is congruent to itself. SVR is congruent to UVT. So that's one pair of congruent angles. And then remember when we talked about alternate interior angles, because those two lines are parallel, you have a transversal. You can say that angle S is congruent to angle U based on their alternate interior theorems going off of this transversal crossing the two triangles right there. So you can say that the two triangles are similar. SVR is similar to UVT using AA. All right, so now looking at solving a real life problem. So we have a flagpole that casts a shadow that's 50 feet long. And at the same time, a woman standing nearby who's 5 feet 4 inches tall casts a shadow that is 40 inches long. how tall is the flagpole to the nearest foot. So we're going to try and use the relationship of the shadows to determine how tall the flagpole is. So let's kind of unpack this and see that we need to find the height of the flagpole, and we're going to be given the length of the flagpole shadow, the height of the woman, and the length of the woman's shadow. We're going to use similar triangles and connect those two things together to create a proportion and solve for the height. And the flagpole and the women form two sides of a right triangle with the ground because they are standing straight up and down perpendicular. Those make 90-degree angles. So that's kind of the relationship of what that looks like coming from the sun casting a shadow on the ground. The X feet is going to represent our flagpole height because that's what we're trying to find. We have the 50 feet representing the length of the flagpole shadow. We have the 5'4" on the triangle to the left representing the woman's height, and 40 inches to represent the shadow. Then we're going to solve this using a proportion. And we have two pairs of congruent angles. So we have the same angle of the shadow coming down because it's at the same time. And then you have your 90 degrees that are making AA similarity theorem. So we know that these two triangles are similar based on AA. So we're going to use a proportion, but we need to make sure that all of these numbers are in the same unit. So when you are looking at something that is 5 feet 4 inches compared to 40 inches, it's best if you convert the height of the woman into inches total. So 64 inches is her height compared to 40 inches of the shadow. So you're going to write the proportion using 64 now instead of 5'4". We're going to go feet to inches of the heights compared to the lengths of the shadow. So this ratio on the left is comparing the height of the flagpole to the height of the woman, then the shadow of the flagpole to the shadow of the woman. And you're staying consistent in feet to inches to both of them. Using your cross product property, 40 times x is 40x, and 64 times 50 is 3200. Divide by 40 on both sides to get x equals 80. Now 80 is going to represent feet, so your answer is 80 feet to represent the height of the flagpole. So let's look back and make sure that we're using the correct units, because the length of the flagpole is given in, because the length of the shadow, is given in feet. We need to make sure that we're looking at the height of the flagpole in feet. If you converted everything to inches, you would need to then convert that back into feet, staying in the context of the problem. I don't think you're going to go anywhere close to a building and ask someone how tall the flagpole is, and they'll tell you in inches. Everything is going to be given in feet for this context, so make sure that your answer is also reasonable in the context of the problem. So 80 feet would make sense. So you can estimate that based on it being an 8-story tall building based on the picture. Again, I know it says it's not drawn to scale, but it's a good, reasonable estimate to see that you are in the correct region of estimating that answer for 80 feet.